Ritik is going to tell you about building a production-ready Meteor app.
Testing. Hey guys, my name is Ritik, and as Andrew just mentioned, I'm working on a thing called Stream. We built our app in Meteor, so I came to give a talk today to give you guys a little more insight on how we did that and how to actually build a production-ready Meteor app. So one of the things that people have been saying for a lot of the past months is that Meteor's this cool technology. It's great for building toy apps, but how do you actually get past just building something that's like 3 files big, and something that can actually scale and I can actually use for my production app, or something that just is something other than that what I want to show on Hacker News or something like that. So basically today, that's what I'm going to go through. Some of the things that we did, how we set things up on our side, and how to actually build something that goes beyond the toy app phase. And questions can come at the end. So there's really 4 components that go into building this production-ready Meteor app, right? So the first one, and I think a lot of people have this question, is what is like the app structure supposed to look like, right? In a Meteor app, there's the examples that show you, well, there's 3 files, HTML, JavaScript, and maybe one other one that's or the CSS, obviously. There's nothing that goes past that, right? So if you want to make one that has multiple pages, has a router behind it, and has a lot of different moving parts, how do you actually structure this app, right? And then some other questions might arise when you're going down this lane. It's such as like, what packages do I use? Like, what is the concept of packages? Which ones are good? What actually will help my app, and which ones are necessary? And then obviously the other one is, how do I actually architect this on a production server so that I can actually get this past one server? Let's say I get a lot of users on this app. Will this thing scale? How can I make sure, and how can I actually load balance everything and get all that stuff up? Things that you might be used to if you've used other systems like Rails and things like that, but it's not as obvious when it comes to Meteor. So these slides over here are more of a resource. It'll be up online, and hopefully you can refer to them at some other point. And people will hopefully build on top of this and release more information about how to do these things in the future. But hopefully this is a good guide to start out with. So one of the general philosophies that that we took at Stream, at least, on building a production-ready Meteor app was that we wanted to keep everything that Meteor does intact, right? So like build around what already exists, right? So that might mean adding packages, or monkey patching some things if things aren't what you wanted to work as, so that's kind of the philosophy that we went with, and that's what I recommend, just because it's really easy for you to upgrade Meteor as they release more things out into Meteor Core, and just makes for a much simpler experience. And obviously, the first step whenever you're doing this is remove the 2 packages that come with Meteor, auto-publish and insecure. These will obviously not work in production. Auto-publish will automatically publish every single document in your database to the client, and unless you control that, which you should be in a production app, that can get bad really fast if you have thousands of documents. And insecure lets anyone do any database writes, which is obviously a security risk, and that was addressed in Meteor a while back. So the first thing is the app structure, and basically I'm going to outline one of multiple ways you potentially could structure an app, and hopefully this gives some insight on if you want to make your own app structure, or how to actually architect this whenever you're doing your big app. So the app structure right now that you probably know of, if you read through the Meteor docs, looks something like this, right? You have the client, you have the server, you have a bunch of other things like the public assets, private stuff. You might have your tests, you have your packages, a common folder called lib, other folders that are common between the server and the client. It's not obvious when you read the docs as to how you want to structure your app just by looking at this. So let's take a look first at the client side stuff that you might want to build. And it might be a little small, but hopefully you can look at these later if you never need them. So on the client, the main things when it comes to the app, you have the regular stuff that you would see in a regular web app, right? That makes your CSS. It's obvious. Your JavaScript, which is your third-party libraries that you might have, like your jQuery libraries and things like that. And then your views and your lib folder. So the 2 things that are really unique to Meteor are these 2 things, right? So the lib folder in Meteor, for those of you that don't know, is the thing that gets loaded first. So Meteor has a special load order that actually loads things based on based on the file name, and the lib folder. Anything in the lib folder gets loaded first in Meteor. So this is a great place to put things like your helpers, right? For example, you have client-side helpers such that might do that you might be doing a bunch of jQuery in a bunch of times. You put this in your lib folder so it gets loaded first and it's accessible in any of your other views or something like that. And then you have your Meteor-specific code, right, that goes in your lib folder because you want this loaded because this is your core of your app, right? And this includes things like your router, right? So the router in Meteor is different than what you might have seen in other frameworks. What I mean by that is that routing is done on the client side. You might be familiar with this if you use other client-side frameworks. But for example, this isn't as obvious if you're using something like Rails. So client-side routing, you put your routing stuff in here. You want that to be loaded, obviously, initially. And then you have these two other files, which are called startup and subscriptions. So in Meteor, there's also this concept of Meteor Dot Startup, right, which is basically code that needs to be run as soon as that file gets initted, or as soon as the client is initializes, right? And you might want to be running, you might want to run some things like set some sessions initially, or seed the database because this client is now connected, or do something initially when the client connects. If you're building a chat application, make his status online or something like that. So that code goes into here. Subscriptions is essentially what you would have to do to subscribe to your actual data, right? So you subscribe, a new user signs into your app, and then you can subscribe to the data, whatever. So maybe it's the chat room. You want to subscribe to all the chats in that room. You want to do it over here because you want to get that data initially, and that's the first thing you want to do before you load anything else. So again, a lot of you might find this obvious. It's all in the docs, but hopefully this gives you a more structured way to put it. The last thing on this one is views. And this is actually where it gets a little more complicated. Because if you're building a large multi-page app, the question is, how do you actually structure these views? And how do you actually route things between them, right? So the way that we do it is we have a views folder. And inside that is you have separate folders for each group, right? And what is a group? Something like accounts, right? Accounts might have your login view, register view, forgot password, anything to do with logging in or accounts of some sort. And you have groups like this, and each view has has its HTML, which is your template, and then has also the JavaScript file, which is the controller, which has the template.helpers, events, what happens on the rendered. Again, these things are in the docs, but basically the point is every group has a bunch of views, and every view has a template and a controller that controls it. So with these multiple views, you can use the router.js file to route things between them. So if you go to a different route, it'll automatically load a different template. And I'll get to exactly what you can use for the router. So the next up, if you go back, if you remember, there was that's a client directory. And that client is actually probably the most important part because this is a client-side app. The next thing is actually the lib directory. So anything that's not in the client and the server folder, in Meteor automatically is shared between both the client and the server. So in the lib folder, essentially you have two things, right, that we usually put, and this is basically the helpers and the models. So helpers, pretty straightforward. Things that any helper model, helper functions that are shared between the client and server. Things like maybe string base name, is valid email address, simple things. The models is a little more intricate in the sense that there's a concept in Meteor of how collections exist both on the server and the client. And in the models, what we do is basically we initialize all the collections that we're using and that we want shared both on the server and the client. What we actually do is we take the concept from Rails on having very fat models in the sense that we abstract all our database queries out to these model files. So for example, Meteor actually lets you do raw database queries directly in the server side and client side code, and you'll see all the examples actually show you doing the actual database queries there. But if you're building a large scale app, you want to abstract these things out to actually more helpful functions like user. In the user model, you want to do like user dot get username or dot set notification setting or something like that. That is a little more descriptive, more Rails-like, but I think it's a little better for your app because it's a more descriptive name. You can reuse it in multiple places without having actual raw database queries littered over your code. So the next part of the app structure, this is kind of the other crud that just goes on with Meteor. You have your packages that comes in from it's similar to what like a Ruby gem or like an npm package or something like that. And you can use Atmosphere or Meteor, right? These are two great programs that'll let you get packages pretty easily. And you have these two folders called private and public. Private is exactly what it sounds like. It's files that are private that you want access on the servers, things like your email templates, raw files that you just want to load directly. And public is all your public assets. And then obviously you have your test suite that you can add, and I'll get into that later. So the last part is the server-side code, right? So in the server, you might have a variety of things, and the first thing on the list is actually the API. So the concept of an API is actually is not documented in Meteor, because Meteor is all about the client and the server communicating with one another, right? And ideally, this would be true for everything. But if you're building a large-scale app, you might have a mobile client or some other external API that a third party wants to hit. And for this, you still need to adhere to REST principles. And this is a great place to put an API and actually declare your routes. So these are like your standard server-side API routes, and you can configure that on the server. Then you have other things like your config. You can configure accounts. What happens when new users created straightforward stuff. Helper functions. You have your lib folder. Again, the lib folder is the one that's loaded first. And this is a great place to load things like what happens on the server startup, or initializing your npm packages or something like that. So everything that you want loaded first. And then you have your models, if you have any server-side models or anything like that. And your publish function, and this one is most important, because this basically dictates exactly what you want to publish to the client, in the sense that what data goes to a client based on what permissions the client has. And again, I apologize if a lot of this is just information you already know, just by reading the docs. But hopefully this gives you some idea of how we actually structure our app and how you might want to do it in the future. So you got the app structure down, and you're trudging along. And actually, how are we doing on time?
About 8
Left?
Yeah.
Oh, OK. So the app structure is pretty important. And there's a lot of good packages that you want to include as well. But I'll skip over this and maybe do this in a different talk then. And you can reference it in the slides. But packages are really important just to actually, I mean, you guys have all maybe used them in different languages. They have the same function in Meteor. This is just a quick list of essential packages, basically a filtered list of what you want to use in your apps. But you can reference it later. I'll go through it maybe in a different talk or something. But the more important thing, I think, the one that hasn't been touched on at all yet has been server architecture, right? So like, you guys know how to deploy an app. You can do Meteor deploy. It goes to meteor.com. You can deploy it on Heroku. All of these things are great if you want to build your small apps. But if you want to scale past one dyno or one instance, it's very difficult to actually figure out how to do that. How do you make something that automatically will scale up? If I have like 100,000 people, or like 10,000 people hitting my website, right? One dyno will not be enough. Heck, maybe even 10 instances won't be enough. I need this to actually work. And this is where we had to think of some other creative ways to get around this problem. So one of the common things that people kind of wrote this off initially. They were like, well, Meteor's not scalable yet. They'll get to it later. This isn't ready for production. And luckily, that's not true. There's actually a variety of solutions, and I'm going to outline one of them. So first, let's start with the problems, right? So there's multiple components that you have to think of when deploying any app, right? And specifically in Meteor, right, there's a few problems. So I mean, there's the standard components. You have to think about how you want to deploy it. Pretty straightforward. You want to have support for multiple web servers, so you can actually scale your app across different instances, right? And you want to have it load balanced properly, and so that you get users scattered across your instances. And obviously, you want to have the core part of your app, the database, has to be scalable in some way. That in Meteor's case, there's a lot of other nuances because Meteor's all about syncing data in real time all the time. So a couple problems arise from this. And number one is that there's a problem of data synchronization, right? Because the entire point of Meteor is that you're always communicating with the server as a client and synchronizing your data to the server so that the server can update the database. And then all the other clients get the updates immediately. This is the entire concept of the whole reactive real-time Meteor app. The problem is if you have multiple servers, how do you, as one client, tell 1,000 other servers what exactly what data to synchronize? So that's like problem number one. Problem 2 is that in Meteor, everything is based off of what's called a sticky session. So how Meteor is built is that a client is connected to a server, and it has to stay connected to that server for that session. So you can't do load balancing appropriately like how Heroku does with round robining, which is called, every time you do a request, it will send me to a different server. And so that's a problem. We have to figure out how do we get around this issue. We can't use Heroku for this, obviously. And third one is the database problem, which I'll get into at the end. So first, for deployment, you want something that's actually something that's reliable. And for this, we chose Amazon. And there's obviously a bunch of solutions out there. Rackspace, Amazon. There's a couple of other ones, Modulus.io, all these other ones that have been popping up recently. But we wanted to go with something that has a good name. And Amazon was obviously the one Amazon was one of them on the top. And for this, we actually used Amazon Elastic Beanstalk. For those of you that haven't heard of it, it's essentially what I would say Heroku for AWS. Definitely check it out. It handles a lot of things like managing server instances, load balancing, asset delivery, monitoring, scaling, and things like that. So it's essentially what you would use Heroku for. A little more complicated, but that actually works to your benefit because it works with Meteor well. So I'm basically going to go through a configuration how we did this and show you a little diagram of how we have the server architected. But essentially, we used, so standard on Amazon is the EC2 instance. That's essentially your web server, Elastic Web Server. These are all details over here. But basically, we're using EC2 set with setting. You can actually set them to do auto scaling, which is essentially if the CPU usage hits 60%, it'll automatically add another EC2 instance. And if it hits below 30, it'll take one down. So this is great because then you don't even have to worry. If you get 1,000 influx of users, then it'll automatically keep adding instances until your CPU is scaled, is leveled off. And if you don't have that many users, it'll take them all down, which is exactly what you want. Now, the second thing that we were talking about is also load balancing, and Amazon also comes with a solution for this, Amazon Elastic Load Balancer. Now, the one issue that we mentioned with load balancing was that you always, remember, because Meteor is built so that one client always has to be connected to the same server, you want the load balancer to make sure that that always happens. And this is the concept of what we were calling the sticky session, right? So luckily, Elastic Load Balancer actually lets you do this. Right. So again, there's details in here, things like the settings you want to set. But it's just good to relay this information, so you can configure this later at some other point. The database now is actually the most complicated part, right? Now you have this entire solution, built out, but the problem still is there's actually two problems, right? The Meteor server itself on each EC2 instance still has slow data synchronization. So one of the things that's not commonly known is that if you have two Meteor servers connected that are running, sending data between each server actually takes 10 seconds. So a server only talks to another server every 10 seconds. So if I'm on one connection and another one's on another server, if we're updating data, we're not going to see each other's changes for another 10 seconds. So the solution to this is actually hidden inside the database. So MongoDB, if you're running a replica set, actually has this thing called an oplog, which essentially is it has a thing called oplog, which essentially fixes this issue. Because what it lets you do is each server can essentially connect to the MongoDB oplog, which basically, and the oplog is essentially a stream of new reads and of new writes that are happening inside the database. So instead of the servers actually connecting to one another and sending data back and forth every 10 seconds, they're essentially getting a real-time stream from the Mongo instance itself, getting data to each one of these servers, and each server is getting this data in real time as the Mongo server is processing it, so that the server itself can update the data that's updated data in real time instead of waiting 10 seconds and push that data to each of the clients. And I would definitely love to go more in depth on how exactly this works and why it's so good. But basically, it's essentially one of the solutions, one of two solutions that will solve the multiple server problem. And currently, you can use the Meteor oplog branch in the Meteor repo, or use a package called Meteor Smart Collections that will let you actually take advantage of this and actually get take advantage of multiple servers and this real-time updating. And of course, you have some extras. I'll skip over these really quickly. You can use CloudFront for CDNing your data. Simple things, just regular deployment stuff. Nothing Meteor specific, really. So I know we're almost out of time, but this is kind of what the diagram looks like. You have your DNS, Route 53 on top. Yeah, you have SSL termination, you have a load balancer, you might have your CloudFront, your scaling set up with your web servers, and your Mongo database at the very bottom. And that's, that is the fat the fat layer, essentially. The Mongo database is doing all the work, making sure the oplog is running, sending all the data, all the updates to each one of the servers, and making sure everything is in sync. So essentially, the bottleneck, if you have this entire Amazon setup, is the Mongo database, and you just have to keep that's basically how fast can you write into the Mongo database becomes the bottleneck and the question you have to ask. So I definitely jumped through this pretty quickly, and one thing that I wanted to that we want to start is essentially we'll publish this so hopefully other people can see it, and essentially start doing a couple of things to actually make this process on building production apps easier. So things like building an app scaffolding system, more guides and tutorials, and we'll share that URL once we get there. But that's pretty much the what I had to say. Had to jump through a couple things, and of course the shameless plug at the end. We are hiring at Stream. A couple details about us. We're one of the larger scale Meteor apps. We're YC backed and venture funded. So if you're looking for a job or interested in working on Meteor stuff on a day-to-day basis, please contact us. Or feel to contact me if it's any other, if you have any questions or anything. Happy to answer questions now as well. Yes, yeah.
I have a question about caching. So one of the things you mentioned is like the database is the bottleneck, right?
Yes.
If it's interactions between users and ferrying those changes out to everyone who's connected, it seems like rather than worrying about how fast you can actually write to Mongo, given like the optimistic model that's used on the client in Meteor, couldn't you do something similar where you just write to a cache and then forward the event on and then write to a database later?
So the question was, instead of doing this, instead of making the database the bottleneck, where correct me if I'm wrong, essentially instead of waiting for the thing to write to the database and then distributing it out, have a cache layer in between where you just write to the cache first and then distribute to the clients, and then the database can update itself. So yes, you can do that. There's actually a package called Meteor Cluster, which does something like that, essentially. It basically uses Redis for the cache layer. So every database query that's done, database write that's done, it sends it to the Redis layer, which then distributes to all the servers, and then the servers update the clients. The oplog just happens to be a faster way to do that for a variety of reasons. And it's actually not, it's not that, it's actually faster to do that. Because I think from what I understood, and there was actually a presentation about this, but the Mongo instance, the primary, will actually write to the oplog as soon as it gets the write, which will happen. It's about as fast as having a Redis layer, there's no material difference between the two.
So you're finding that you're not bound by I/O to Mongo?
No, yeah, not yet. Yeah.
I'm interested in the client layer. You've had a lot of the grouping system that you have in place.
Yeah.
Where does partials come in that? Because it seems like those groups have to be predefined and are pretty static files in there. But if I want something to move around,
yeah.
Let's say I want to have like a movie list or whatever shown a certain way in one template and then another way in another template. Usually I will put it in a partial and just like call it back. Where do partials fall in this model?
So usually you want to put them in a folder called common, /view/common. So that's like, for example, if you have a layout, you want to put it there, footer, sidebar, maybe this, because it'd be appearing on multiple pages. Or you might want to think about, and again, this is on a design preference. If this is appearing in two different views, maybe both of those other views should be in the same group as well. Maybe it should be the movie group, and then you have this partial, and then you have the other two views in that folder as well. Again, a design preference, but yeah. And sorry, for anyone on YouTube, the question was, what do you do with partials, and how do you structure them within this app structure here?
Any other questions?
Yeah.
This might not be Meteor specific, but when you've got sticky sessions and you're talking about the CPU dropping below 30%,
Yeah.
do you have to hold on to it
So that's a good point. The question was related to sticky sessions. If even one user is on, is on another server, and you're scaling down because the CPU usage is less than 30% based on the autoscale permissions, what do you do with that? Do you keep the instance alive? Luckily, so I don't think this is the case yet with Meteor, but because we have the oplog solution or the data synchronized solution solved in some sense, eventually you should be able to you should be able to just make the user go to any server, right? Because if you think about it, every server should be okay with any user connecting to it at any point because it'll be up to date in the sense that it'll have all the up to date data, right? But that's not the case right now with Meteor. So yes, you're right. You do have to keep the server alive until that one last user leaves. Yes. Yeah.
In the case where you're switching a client from one server to another,
yeah.
when there's a WebSocket there or some long hole that
yeah.
has to be renegotiated,
yes.
how well is that handled?
So the question was, in the case that you switch a user from one server to another, you have to renegotiate the WebSocket or the polling of some sort. How well is that actually implemented? Again, it hasn't been implemented in Meteor. You're right, that is a problem. There's specific session state you might have to pass back in a renegotiation. Again, I'm not exactly sure. Maybe you'd have to ask the Meteor guys. I don't even know if this is something they would want to do on the roadmap.
Any other questions?
Yeah.
How did the conversation go when selecting Meteor as your platform for this kind of license-backed startup you're doing? What were the benefits and trade-offs and the kind of things you guys discussed? And kind of basing it off of this.
So the question was, how did the conversation go when deciding to use Meteor.js over another platform that might have more traction of some sort, especially because we're a company that's running this in production, YC-backed, whatnot. So I guess what we decided was we wanted to build a single page app because that's the feedback we got. And looking at the single page app frameworks, there was Angular, you can use Backbone and build around it, Ember.js, a lot of these other solutions. But I think at the end of the day, it came down to we thought that we knew the Meteor guys, and they're really approachable and accessible. B, it was this is exactly what we would have eventually had to build towards, right? Even if you're using Angular or one of these other frameworks, you eventually have to build a lot of this glue to make it work like how Meteor works right now, right? Basically, we decided that those two reasons were good enough that Meteor is a contender. And C, I would say we chose Meteor based on just evaluating it on how well it would work in all these conditions, right? Can it scale? Does it work well in production? Is it secure, right? And this is all after Meteor had fixed all these issues that you might have seen previously. And yeah, so I guess it is a risk, right, using something below version 1.0. But I would say the benefits are really nice because you get all the data synchronization, reactivity, and all these other things that you would have to build yourself if you want that in the app. So yeah, that's the answer to that.
All right, thank you. Thank you,
Cool,
Ritik.
thanks.